All right, guys, lesson 7, homework problem starting on page 182. Here's a graph for each interval. Decide if the average rate of change is positive, negative, or zero. Is the graph going up, down, or staying the same? So from 1 to 5, our graph is decreasing. It is negative. Better answer, negative. 5 to 7. So 5 to 7, it doesn't change. It goes down and then back up, pretty well level. So I'm going to put 0 there. 10 to 20, definitely goes up and then back down, but it is higher than when we started, so the rate of change is positive. 15 to 18 is negative. 20 to 24 is negative as well. Question number 2. Was a person walking faster from 20 to 40 or from 80 to 100? So which one is steeper? And that is certainly 80 to 100. How about from 0 to 40 or 40 to 100? That one's pretty close. I think this one looks like he certainly, it's like sprinted to start. This one is kind of a higher sprint area, steeper. So I'm gonna go with 0 to 40. Question 3, matching. Squirrel runs up the tree very fast. So the average rate of change would be positive and go up very quickly. Starts and ends at the same height. Starting at the same height, that'd be 0 change. Runs down a tree. So runs down a tree, it would be negative. So that goes to 1. Runs up the tree slowly. Positive. And change is going to be small. Question 4, determine the average rate of change for P between 1992 and 2000. 1992 to 2000, rate of change. Okay, so it looks like it went down. How many voters there? So 34.5 minus 42.7 went down 8.2% of the vote, and that is in 8 years. So that's an average of just over 1% increase or decrease per year. Pick 2 different values for t so that they have a negative average rate between the 2 values and determine the rate of change. So pick any 2 where it goes down. Let's just pick those 2. So 40.9 minus 48.4, and that would be 4 years, 2012 minus 2018. So 40.9 minus 48.4 is negative 7.5 divided by the 4-year span. Goes down almost 2% per year in those 4 years. Question 5, pick 2 values so that it is a positive rate of change, so one that is going up. Let's pick 98 to, let's go to the end. 98 to 2016 overall, it went up there. So 43.4 minus 35.7. And that would be from 2016 to 1988. So 43.4 minus 35.7 is 7.7. From 2016 to 1988 is a 28-year span. 7.7 divided by 28. 0.275% increase in those 28 years on average. On average. Jada walks to school. The function D gives her the distance from school. So this is the distance from school. This would be our time. So what does it mean in this scenario? Well, after 10 minutes later, 10 minutes later, Jada is 0 meters from school, is at the school. Or 0 meters from school would be fine as well. Question number 6. Using the same thing, Jada is 600 meters from school after 5 minutes. So 5 minutes is in the parentheses. That gives you 2 choices. Our distance equals 600. So your answer is A. Question number 7. What is wrong with the claim that vending machines are causing our youth to miss school? Yeah, again, it's a scatter plot. And I don't know any kids that miss school based solely on the number of vending machines in the school. So it is a scatter plot. There's going to be no cause and effect. It might be an association, but it is not a cause and effect. Kids are not coming to school because you took out their soda machine. What is a better headline? Vending machines may have minimal impact on student attendance. Again, just whatever you think there. Obviously, again, there is not a cause and effect relationship there.